So, welcome everybody to our SpecimONE webinar, where we are going to introduce our new spectral imaging platform. And also, in case there is anybody from US, happy Thanksgiving. So, my name is Jorma Axelsson. I'm the product manager at Specim. So, I will be presenting today with my colleague, Mr. Mathieu Marmion.
Hello, everybody. Mathieu Marmion from Specim, Senior Application Specialist. I'm happy to be with you tonight.
Thank you, Mathieu. So before we go into the actual webinar, just a few household rules. We do have a Q&A session at the end. So yes, you can type your questions in the chat window, and we will go through those at the end. And I hope you will have lots of questions. So more interactive is always better. All right. So just a few words about the Specim as a company, in case somebody out there is not familiar with us yet. So we're actually celebrating our 25th birthday this year. So it's been a long ride. So company was established already in 1995. Headquarters is in Oulu, Finland. We do have also direct presence in Helsinki, the capital of Finland area, in China, as well as in US. Currently, we are about 70 employees globally and supported naturally by our worldwide distributor network. And if looking during the 25th years, we have already deployed more than 5,000 hyperspectral cameras globally. So before we jump into the actual SpecimONE, explaining what this spectral imaging platform is, maybe a few words first that what is the hyperspectral imaging? And I hope, Mathieu, maybe you could give us less than 2-minute explanation. I'm sure you can do even 30 minutes if you want, but maybe just a short one.
Well, it's more difficult for me to have it short, like for the presentation, but well, hyperspectral imaging is a nutshell. It's a combination of spectroscopy and imaging. So basically, you take an image, and for every pixel, then you can have like a full spectrum. And because every different type of materials, they have different type of spectral signature, it's possible to see by identification, like a fingerprint, which material is what. So the typical example you see below, you have like some different type of plastics, and then with a camera which is there, you can see over a line like this, and each pixel of the line having independent spectral information. You can see the illumination, and still it's possible to obtain the classification there. So if you could remove your camera just a little bit, that we could see a bit better the classification. Here's wonderful, Jorma. Thanks for disappearing. So here we can see like the classification. And basically, this is what you can achieve with a hyperspectral camera. So it's widely used in research science and remote sensing. It's also used in the industry, and we see the growing trend over there. And it allows industry to improve their process and also quality control, things like this. All right, so I think that was my introduction about what hyperspectral imaging is. Of course, the integration of those, they have some challenges, and I'm sure that Jorma will be happy to explain about those challenges. So please go ahead.
Well, yeah, obviously, if looking at the industrial customers, like industry requirements, so companies, for example, building material sorting systems, so the machine builders, they want to have a best possible accuracy, meaning that when you're sorting materials, more, or let's say better accuracy you have, obviously it means better return of invest. Same thing goes with the performance. So faster you are able to sort the different materials, at the end the system throughput is better, again meaning better return of invest. And well, I would say that in general, maybe Mathieu, you can also jump in, but if thinking especially the accuracy, with certain materials, yes, I'm sure people are using RGB cameras and such, but then on the other hand, I guess the spectral imaging in certain applications is pretty much only feasible way. maybe Matthew, you have some examples.
Yeah, well, like there are some plastics. Some of them, they have really clear different spectral signature. So in those cases, of course, even like multispectral RGB camera will be able to do the work. But with hyperspectral imaging, you are able to separate things with really tiny spectral differences. For example, different type of plastic, which are quite similar somehow, but still with tiny differences. So the hyperspectral camera can do that. And also the good thing with the hyperspectral camera is that it allows some adaptability. So it means like if one day you have a sorting machine and you have some certain plastics that needs to be sorted, and if the next day you want to sort some other one, you can really tune your system so that actually you select the right bands depending on your application, that you can sort the different type of plastics. And here actually come also the strength of the method. If you will be using other methods, which will be more like a multispectral camera, you are fixed with those bands and then you lose this flexibility.
Yeah, exactly. That was a good one. So, okay, summarizing requirements: better performance, better accuracy, flexibility. I guess those are pretty much the key things. But then if looking at the challenges, so like in the mentioned, so the spectral imaging as a technology is definitely a growing one. So it's getting more and more common. So looking at the different machine vision systems, so they are starting to take this technology in use. But let's say it provides great accuracy, ability to detect these materials. So why it is not deployed everywhere yet? So yes, in certain application areas, so yes, spectral cameras might be more expensive compared for the, let's say, RGB cameras. But then on the other hand, yes, you will get lots of benefits out of that. So I would say the cost is probably not the major issue. But at least what we have found out that when deploying the hyperspectral imaging technology, it requires a lot of knowledge. So you need to understand what are the results, how to actually read the results to detect the different materials. Also, okay, maybe the tools out there are not so flexible, user friendly. Quite often when deploying this technology, like cameras, for example, from us, often the machine builder still had to go to get the software from another vendor, get processing hardware from another vendor. So yeah, it took complicated, and let's say it was, or let's say it has been quite time consuming.
Well, if I can summarize quickly here, indeed, as you say, so it requires some knowledge, either in chemometrics, either in computer science. And those knowledge, either you have them in the company, either you don't have them in your company. So you have sometimes the need to outsource them. But here, actually, we acknowledge and we recognize as a challenge that quite often we are discussing with people or with potential integrator that the usage, integration software-wise was a bit difficult, or it seemed to be difficult, and the interpretation of the data was another thing. And actually, that's why here we come, Roma, right, with SpecimONE, because it's offering a platform, we will show in the next slide, how to make all those challenges easier for the integration and for the usability.
Absolutely. And that's where we come to this spectral imaging made easy, which is driving Specking as a company. So now the SpecimONE, our new spectral imaging platform, this is something where we absolutely want to make things easier and faster. So SpecimONE as a platform consists of three different parts. So we do have an application called Specking Insight. So this is an easy to use software tool to export the data and build a classification models. And then these models you run at our processing hardware named Specking Cube. And obviously one important part of the whole platform is our award-winning Specking FX cameras. So now here we are bringing totally new approach to our customers to have a easier and faster way to start using this technology and also provide the performance and flexibility. So if looking at these different components, a bit more details. So yes, we do have these Specim FX series cameras. For example, the Specim FX10 for visible and near infrared going 400 to 1000 nanometers. FX17 camera from 900 to 1700 nanometers. These are the cameras we are supporting now with the SpecimONE after our first release. We do have the second release coming, where we also will support our FX50 camera. It goes up to 5300 nanometers. It's a great camera, especially for black plastic detection. So these are the cameras actually then providing the information images in real time to our Specim Cube. So this is our high performance processing platform, where we are running these material classification models that we have built using the Insight. So as a platform, the Specim Cube, it's highly optimized. So if looking the software we run there, it's designed to meet all the industry requirements. So best possible throughput, meaning how many frames per second we are actually processing, minimal latency and jitter time to provide fast results. And then last but definitely not least, then the Specim Insight, the actual software. So easy to use Windows application where you can build these classification models. So you can explore the data and then you take the test data in, you start building your model. Once you're happy, then you put it running in a Specim Cube in a real time. And it is where the what Matthew is then soon going to show in his demonstration. But before going to demonstrations, just quickly highlight the actual system architecture. So let's say when you start using the system and you want to build high performance flexible material sorting. So you run the Specim Insight application, you take the test data sets in. Yes, you can take it also using our FX camera. But once you have the data set there, you start building your model, you train the model, you validate the model. Once you're happy with the result, you install the model to Specim Cube. So basically here, you start running it in real time. So we get the real-time stream coming from the cameras, inspecting materials, for example, at the conveyor belt, or could be free-falling system. Process it based on the model you built, and then the classification results are then streamed over the Gigi Vision to third-party system, like could be some machine vision system or some other sorting machine logic behind there. So this is roughly the principle of the system. Okay, and then now if looking at the benefits of this system, so definitely we can enable the faster integration of this spectral imaging technology. So Insight, Specim Insight as an application, so easy way to create these models without having this in-depth spectral imaging technology knowledge. So intuitive software, as you will soon see. And then once the model is created, easy to install and run in Specim Cube. And also as Specim Cube supports like RGB8 stream over the Gig-E interface, it will be easy and let's say seamless integration with the most of the machine vision systems. And definitely the performance, so high accuracy combined with Specim FX cameras, so great optical characteristics. We can optimize the performance also at the camera side using the features like MROI, the multiple regions of interest. And then when processing the information at the Specim Cube, yes, as mentioned, it's highly optimized to provide the best possible throughput with very small latencies. Anything to add, Matthew, here?
No, not really. I think you made a good summary of the situation. Basically, you need to use an FX camera, FX10 and FX17, camera link interface. You connect it to the cube. In the cube, you have the possibility to acquire data. Once you have the data acquired in there, you have about 1 terabyte about data which can be saved in there. Then you can import the data into your laptop or your computer where you have the inside software. There you can build your model, convert it into an application, and the application you can then load it inside the Specim cube a little bit, because in the same fashion as a runtime, and then the output in real time will be then streamed through the GigiVision interface. We have seen there has been quite a lot of questions as well, but I think first we will go through the demonstration and the end of the slide, and then we will go through the questions.
All right, then I guess it's the time.
That's the time for the demo. Just one thing about the demonstration. As you can see, we are working from home because, because of the pandemic, we are not really able to be together like this as freely as we would like. So the demonstration has been recorded before. So it will be streamed to you as a video, and then we will come back, me and Jorma, to talk to you and to take the questions. With inside here, there is the dataset folder and the detected device. The detected device, it could be the cube. Here I will add a new device, and automatically it finds our device. Here we are. Data are now in here. Then I could select them as a training dataset. Data has been loaded, and here there is browse, explore, and training. When we are making an application, we only need to go to training. Here we are, and the dataset is actually collected in here. Then we try to build a model. To build a model, first you have to make some region of interest. You have different tools for this purpose. First of all, you can zoom and unzoom on your dataset. Those are reflectance data. And then you can select different type of region of interest you want to have. It could be a rectangle, it could be an ellipse, it could be a lasso, and some other one. So first I will take the lasso selection. Here there is the first almond. Then we will select a shell. And then we will select some background. Like this. So here we created 3 different types of region of interest. Here the spectra could be visualized as well. The almond was related to the first region, which is here. It's going to be classified in green, and I will keep it with the class ID number 1. The second one was related to the shells. I will give it another class ID. It's going to be number 2, and I will give also another type of color. Why not in blue? Finally, the background here will be classified in black, for instance, and I will give another class ID, which is going to be 3. We selected those 3 classes, and then a model could be based on those. To do so, we only need to train the model and to test it. Here we can see already the classification results is quite good. It is, however, possible to tune it even a bit more. So to do that, we don't need to see that anymore in here. I forgot to mention, by the way, the main algorithm we will provide here is PLSDA 1 versus all or all versus all. 1 versus all is more accurate, but it takes a bit more time for the processing. So in order to improve the model, it was already good, but it's possible to make some other things. We can make some other region of interest. For example, another one could be here. And we can say that it is indeed again a shell, again an almond. It could be classified with the same color. For the shell, this time we will take a little bit of inner part in here. And again, we can tell the system that it is going to be classified like this as a shell.
It is also possible to add some pre-processing steps. Here we have the Savinsky-Golay, which can be added. And with the Savinsky-Golay, some parameter can be adjusted. First one, it is a filter width, could be for example 15 pixels. And also it's possible to put a polynomial order about the fitting and also a derivative factor. So here it's possible again to train the model with a new region of interest and also the new processing step. Here we can test again. And results are again really good. We can compare to how it was before. It was here the previous model, here it is the second one. Actually here it seems that pre-processing did not help. So basically what we can do, we can remove it, remove, and we can also remove here the region if we are not happy with them. So here there is a high flexibility. Again, we retrain the model and we test it. And we can see the new prediction again. Once a model has been made, we recommend to save those regions of interest like this, save, cube video recording, and here it's going to be, give it a name, demo ROI. Then we can save the model. And once the model is saved, it's possible to convert it into an application by clicking here on Publish As. We give a name, almond and nuts sorting. Now we know it has been published successfully. We can go to the App tab, which is over here. And then here we see that there is one application which is now available. We open it, almond and nuts sorting. We click on it, we can right click on it, we can install the application, and this new application is now installed inside the cube. There is always a reflection streamer, and there is also almond and nuts sorting. Then we don't need to have any more the inside software like this, but we can go back to the web UI. For the web UI, here we have the application. We can select which application we want to use. It was almond and nut sorting. We now select it. We can now go back to Lumo Scanner to control the scanner once more. We turn it on. And finally here we can have the application which is running. Another thing which can be done is when you are making your model, you can actually select some region of interest. So to do that, you need to go back to Insight, which is over here. And we can go back to the training session. Here we can, like this, select a region of interest which we believe is relevant. An important feature with the FX17 is that the first and the last row, they have to be like this with even number. So here, for example, 40 and 110. We can retrain the model with those. So for example here, band number 1, which corresponds to the band number 1 indices, which is here. We can retrain. We want to see the actual results, so we don't need to see visualization here, and we can test again. And we can see again that the result is pretty good. So actually we are going to use this region of interest now and load it within the cube to make a new model. So here we can save again the model. So demo model, and this time I will say with a ROI. Save. Then we can publish it. We go back then to the application. We have again a new application available, this one. Right click, install the application. Then we can add that one now into the cube. We can now go back to the web UI. Remember that when we were using all the wavelengths we had 224, I mean the full spectral range. So now we selected only few. So this time we select the new application here. If we go back to the camera parameter and we turn this on, we will see that the detector size will actually decrease, and significantly. Here we can see it. We could also see it from the spectral plot. Here we see that we are using much less band, about 70. Since we change the region of interest on the detector, we need to reacquire the dark and the white reference. So first I need to move the scanner over the white reference. Here we can update again the white. And we can update the dark. Once we have done that, we are ready again to launch the application here. To have it running in real time, I need to move the scanner, of course. And here we can see again the application running.
Thank you, Matthew, for well-recorded demonstration. Obviously, it would have been great to have it done in real time, but like Matthew mentioned, the corona situation is what it is, and we need to respect the rules. So we are going to jump to the Q&A quite soon, but before that, we do have a poll here asking about your opinion about the hyperspectral imaging challenges. So you should find it soon there at the right-hand panel. So please do give your opinions to the polls. I guess while you are giving the responses, we can then jump to the questions. We can see that there's lots of questions sent already.
Yeah, so just before to jump to the question, maybe I would just say that as you saw during the demonstration, so the cube is somehow having a web UI, so user interface where you can acquire data. Data acquired, you can then transfer them from the cube to your computer using like Inside directly or using some FTP connection like FileZilla. Once you have the data, you can open them in Inside. With Inside, you saw the software, you can look at your data, you can also make a model that you can then convert it to an application that you can then, after that, load inside the cube, and then you have the real-time output with the cube that you can visualize as well with the user interface, the web user interface. Some other GigiVision protocol could be used for this. For example, some people are using eBus player, just out of the cube. All right, so now let's move towards the questions. The first ones, it was about the spectral range of the camera, and we saw that the moderator is Harry. You don't see him, but Harry Karpina, he's doing a fantastic job behind. So he has been answering to those ones. Then the next one was, how do you illuminate the surface to analyze this wide range? Okay, so by the wide range, I think you mean the first one for the FX10, which is between 400 and 1000 nanometers. And then there is the next one between 900 and 1700. So the first one and the second one could be illuminated with halogens. Of course, you can use them. You can say that it cannot be used in the industry. Well, it depends on which one. For example, if you're in the recycling industry, there is no problem to use halogens. But if
I guess it refers that the regulation that the industry is moving out from the halogens because of
that's why I was saying that then you can move as well toward the LEDs. It's possible to use LEDs. We know that some suppliers, so I'm not here like to really advertise them, but we know Metaphase, we know CCS, we know some other ones as well. It's also possible to take into account supercontinuum laser. There is this type of illumination which are available. And then for the FX50, because the question was here as well, we are more in the thermal infrared. So the illumination looks like an electrical barbecue or a toaster, something like this. But we have one as well at Specim, which is designed for this spectral range. Are these applied in hazardous area requiring ATEC explosion-proof enclosure? By hazardous area, for example, like we have casing that we could use with the FX10 and with the FX17, and those they have some standard which are IP67. The camera itself, it's IP52. So yeah, that's what it is. They have been tested as well for vibration. These kind of things, they could be used sometimes on the drones. So they have been tested for kind of robust environment as well. But of course, if you put them close to an explosion, that will not work for a long time.
Yeah, that hasn't been the design criteria. Although it's definitely for the industrial use, but I would say that in most of the deployments, the cube as a hardware is in a kind of machine, like a separate cabinet where they keep all the other computer devices. That's probably the most common one, right?
The next question was, does the box, the cube, connect with the sphere camera as well? At the date of today, no. Only the FX10 and the FX17 they are supported, and the camera link version. In the future, there will be as well the FX Gigi cameras, but at the date of today, we are talking only about FX and FX17 camera link. And be aware that to be compatible, those cameras with latest firmware will be compatible. So it's possible to upgrade the firmware like remotely. We can do that, but the requirement is that they are equipped the camera with latest firmware.
Yeah. So like Matthew said, so yes, today the first release FX10, FX17 camera link cameras. Although the output of the cube is always Gigi. Next release. FX10, FX17 Gigi version supported as well as FX50, as it is a Gigi camera. Also note that when building the applications with Insight, we can also then in a coming releases load the models also to our AFX cameras. So in AFX cameras, we do have some built-in processing capabilities, so we can also take benefit out of that. When inside the camera like AFX, okay, the processing power is probably not as great as compared to Specim Cube, which is highly optimized system, but still some applications can be done already inside the camera.
The next question from Jakub was asking, is there a possibility to perform blob analysis? I'm not sure to know what is a blob analysis, but you saw me like I was looking at my mobile phone and I was typing, what is a blob analysis? Did you know, Jorma, what is a blob analysis?
No, only blob I know is the comic book X-Men. There was this villain.
That's a bit different. So here is like the ability to separate object apparently compared to their surrounding based on color, brightness, or things like this. Well, here, I don't know if it fits really well, but just to explain you, our hyperspectral cameras, they measure spectra. So basically, they give you the possibility to separate objects based on their spectral signature, based on their spectral reflectance. And then this is compared with PLSDA algorithm, and then it's possible to separate them from each other. I don't know if here blob is exactly what you meant, but if I don't answer to your question, then maybe you should contact afterwards and then we will discuss this.
Yeah, there has been some discussions ongoing regarding the object analysis, and let's say, yeah, it could be something to be done, but I guess like Matthew mentioned, it's not probably something where you want to use the spectral imaging technology. Although, yeah, something to be considered for the future.
Then we had Felipe. Hello, Felipe. By the way, our Brazilian distributor. Happy to see you here on the chat. Yes, you mean the cube. You can call it the box. I'm fine with that. Shall latency? How much are we talking in terms of milliseconds? That's an interesting topic. You know the latency. What do you have something to say or?
No, well, I let you to answer. I can then jump in.
All right. The latency basically it depends on many things. It depends first of all on the processing algorithm you are using. It depends on that. It depends if you have some pre-processing. It depends as well the amount of band you are using, because with the FX camera, it's possible, to select the full spectral range, but also some region of interest, spectrally speaking. So that means like region of interest, frame rate of the camera is another thing. Then if you consider the algorithm, the number of classes as well that you want to sort. If you want to sort only A from B, or if you want to sort A, B, C, D, E, F, that's even more difficult as well. If you add some pre-processing, all of those, they have an impact on the latency. But just to give you a kind of example, we were sorting, I think, at 100 frames per second. It was like class A from class B with quite simple analysis and pre-processing. We were below 10 milliseconds. I think we were between 5 and 8 to the best of my memory. But again, those numbers, they really depends on your application, but we are talking about this type of latency. Also with
Matthew, you missed 10. It was close to 1000 hertz with 4 classes and still under 10 milliseconds.
Sorry, 1000 hertz. Oh, my mistakes. And then here it was like this type of level. And another thing is like with the SpecimONE, you can proceed with batching. So that means like you don't have to process each line of the camera at once, but you can say, okay, I acquire, for example, 10, 20, 50, or I don't know, 100 lines together, and then only I will do the processing. So somehow this has an effect as well on the latency. And you're correct, it was 1000 frames per second. It was not only like 100, sorry. What is the expected pricing range for delivery in the EU zone? So here I have to say part of the participants, there are some are our competitors. So welcome to our competitors. We're happy to see you. I think it's good like to have competition. It means that there is a business, there is a market, but you understand we don't want to give this type of information in the webinar here.
Yeah, you can always contact our sales team or the distributors, and I'm sure they are happy to give you a quote.
Then, is it possible to do area scan instead of line scan? For example, if I want to inspect a 2 mm by 2 mm area over time on a static object. Well, here's different. We are having hyperspectral camera, and all our hyperspectral cameras are line scan device. If you want to monitor an area, you need to have a scanner. So basically, we have the camera, we can have a scanner. So the camera will be looking here, the scanner moving underneath this, and line after line like this, you can reconstruct the hyperspectral cube. We have a camera which has a scanner integrated. It is IQ, and this one operates between 400 and 1000 nanometers. So this is what we can offer here. Frans van Demage, one of our distributor again, is from Netherlands this time. Hello, Frans. Can the software train on different images? Yes, you can load as many images as you want. I know you want to put hundreds, but don't do that. But you can put easily like 4, 5, 6, 10 images. It's not a problem. Can you identify analog number instead of classes? For example, estimate the sugar content. All right, so at the date of today, the algorithm which is inside the IQ allow you, inside the cube, sorry, allow you to sort A from B. So basically, it's done for qualitative data analysis. This is used for recycling industry, or for example, in the food industry to detect some contaminant. If you want to go for more regression model, we will go towards this direction, but we don't know yet when. So this is not at the date of today for sugar content, for the bricks level, for example.
Yes, the quantitative analysis is in a backlog, in a roadmap, so definitely something we are looking for. And yes, please follow the news.
How do we identify a region of wavelengths of interest? That's a good question. Well, first of all, by looking at the spectra. When you look at the spectra, when you want to sort A from B, you just look at the spectra of A and B. And then by yourself, you can see where you can separate them because you see the spectral differences. Another way to do could be, for example, to make a principal component analysis. In our software, we have the principal component analysis as a tool just to explore your data. And then you can try to look at different regions of interest. Unfortunately, at the date of today, the user doesn't have access to the loading, for example, of the PCA. But this is something we may consider like to help the user in the future. This is not done yet, but this is actually something we think about. Otherwise, I would say just by looking yourself at the spectra, it's already a good clue. Please give us indication of pricing. No, well, I already explained that here, this is not the right time to do that. Do you have examples of working with fluids like slurries and solid? Okay, so now we move a little bit out of the SpecimONE alone. It's more like an application question. When you go with the fluids, you always have to think that mostly it's water, and water absorbs a lot the radiation in the NIR. So when you have something which is extremely wet, all the spectral features which are above 1200 or 1300 nanometers are not really useful, or just that the water acts as a mask. So it's a little bit tricky here. No, there are not so many applications as far as I know in hyperspectral imaging for those, for slurries. Having said that, with the FX17 camera, you can measure moisture. It's not really fluid, but it's moisture. Moisture level can be done. What are the pre-processing methods available? At the date of today, there is mean centering and also Savinsky-Golay, where you can adjust yourself the size of the average windows, like how many bands. You can set up the polynomial order you want for this fitting and also the derivative. What is the classification efficiency for a few class? Does it drop with the amount of class? If not, does it still apply to 10, 100, 1,000 classes? Okay, so here we have a SpecimONE which is dedicated to the industry. And typically in the industry, especially when you have a conveyor belt and you want to sort contaminants, or if you want to sort, like, for example, nuts from the shell, you don't need to have 1,000 classes. Typically you have maximum 10, but you don't go to 100 or things like this. So we did not try this type of thing, and I have to say it hasn't been designed for this type of classification as well, to have 1,000 classes. So we have tried, I have tried myself up to 10 or 15 classes. That was performing well. But again, you ask what is the classification efficiency? Again, it depends on what you want to sort. If what you want to sort is really distinctive, spectrally speaking, it will work really well. If spectrally speaking, it is very close from each other, then you may have some issue. But I have to say, with inside software, there is the possibility to train, but there is also the possibility to validate your model. And when you validate your model, you have access to a confusion matrix, and this will give you an idea how it performs in terms of classification and what it should be. Can you also scan textile and tell what the material composition is? Yes. That, yeah, thumbs up. Yes, basically, and here I encourage you to look at our website. I think on our website we made a case study about textile recycling, and I must say that I know pretty well because I have been participating quite much in this case study. So basically, yes, you can separate what is made of cotton, what is made of linen. what is made of synthetic material like nylon, which is polyamide, and also polyesters, because those have different spectral signature. And again, because textile nowadays is ending up like in in just outside in landfill, it seems that it will be mandatory, at least in Europe, to recycle the textile. So here, yes, the FX17 will be a good tool for that.
Hey, Matthew, Chris pointed out that we actually missed his question about that. Will the Specim cube classification be a black box, or will the operator be able to modify this from the conventional workflows?
Sorry, I did not see this question. I went over. So basically, it's not really a black box, because you know that the algorithm which is going to be used, it's PLSDA. So you know that. Also, you can choose yourself the pre-processing that you want to do. Having said that, at the date of today, we will restrain, I can say that way, the user to actually to what the user interface allow him to do. But we have the idea that in the future, maybe in 1 year or something like this, that the user will have the possibility to tune the model by doing some coding. I don't want to go too much in this detail, but maybe already, Jorma, we can say that the core of the inside software is based on Python. And then in the future, we think of giving the possibility for the user to play with that.
Yeah, exactly. It's something that we are looking to make it more open solution to allow the customers to do certain modifications at least. So we are happy to discuss this further if needed.
Is the software capable to handle a series of PLS detection like a decision tree? No, we have only PLSDA at the date of today. We have two ways of doing it. We have like one model only, so it means like it will be one model, and then you will try to find what is the best match with the different classes. And we have also the possibility to have one algorithm or one model per classes, and then the best one will be chosen. So, but no other like type of modeling at the date of today. What is the longest distance the camera can be from the object? Very far. So, for instance, you can use the cameras, the FX10 and 17, they have been used in drones. You can measure targets which are really far away. Yeah, no, there is no really distance. Then the question is like which type of spatial resolution you want to have. The camera is looking at a triangle like this. The further away, the bigger the field of view is, so then the bigger the pixels they are. I would say, on the other hand, the shortest measurement distance here with the FX10 and 17 with the 38-degree lens is 10 centimeters. Okay, so here it depends on the optics and the strength of your lighting system, yes. Are morphological operations available in SpecimONE? For example, erosion, for example, or dilatation? No, we don't have morphological model. It's only line after line, and we don't have like shape recognition. Sorry, I think you missed my question. Will the Specim cube classification? Okay, that was a black box. Yes, that's the one we missed, and I answered. Sorry, Chris, we got it. Once you have the results of the classification in the browser as you showed, Specim Cortex, how do you send the information to the control system? So basically, the cube, the output of the cube, it is GigiVision compatible. So you can just connect with the Ethernet cable to the cube, and then you get through, okay, there is a GigiVision protocol. We have also our own UDP protocol where you can actually get the output from the camera. Jorma, do you have anything to add in here?
Yeah, currently the way most of the people are using it's using the RGB8, so it's RGB8 over the GigiVision. Other ones are also possible. So let's say RGB8 is probably not the best possible choice for all the different type of applications. So If you want to improve the performance even further, maybe using like mono 8 just to have basically the classification results. Yeah, this is also something that can be done.
Okay, then do the Specim cameras, IQ in particular, do an automatic dark reference using a shutter? Yes. Then the next one is what kind of data filtering, usually median, can be applied, both in spectral and spatial domain? In the spectral domain, in the spatial domain, or in the spectral model as well, you can use what we call binning. So if you think that you need to make an averaging, for example, of your band, you can already set up with your camera, instead of acquiring 224 bands, if you think you are fine with 112, then you can do what we call binning. So it will take 2 bands next to each other and make the average. It's a kind of averaging already. And the binning is like ×2, ×4, and ×8. And you can do it in the spatial and in the spectral direction as well. Then, if you are talking about type of filtering again, we have the Savitsky-Golay available. Could something like identifying a fluid layer on top of an object be achieved? Yes. For example, we have made a feasibility not a long time ago about, like a pouch where you have inside like apple, kind of apple juice, like apple pouches, what you give to the kid, you open it like this and you just take it like this to see if there was some leaking, or if there was some oil, or if there were some fluids at the top of it. And here, indeed, it can work. It could be used as well for the detection, for example, of oil at the top of like bread or like whatever you want. So it could detect this type of things, yeah. Is there a way to quantify the accuracy of the trained model? Confusion matrix. Yes, I answered to that one a little bit before. Okay. Is the embedded processing capability of an F-18 works the same way as the Specim cube? Jorma, do you have anything to answer?
In principle, it works at the same way. So this also applies to our AFX, the new airborne cameras. So we do have a similar processing capability inside the camera as in the Specim cube. The difference is more about the performance. So the Specim cube is using the, let's say, latest state-of-the-art GPUs, meaning this NVIDIA Xavier series, while then the FX50 and AFX 10 and 17 and the FX50 are using the older generation, the TX2 GPU, which is not having that great performance. But still, in certain applications, it's probably perfectly
fine. Then there is the next question. By the way, I'm sorry if you hear my son. He's behind the door. He's making a hell lot of noise. I'm sorry for that. Do you normalize the reflectance to what references? How you deal with high reflectances? Okay, so basically we normalize with the white and also with the dark references. So basically the dark references is acquired by closing the shutter that you have inside the camera. So basically you measure the dark noise of the sensor. The white reference is like we have a white reference tile that you put underneath the camera like this, and this tile is reflecting perfectly well the light between 400 and actually 2,500 nanometers. So it's really fine for FX10 and FX17. So this is the way we do. So the normalization, the formula is quite simple. Basically, you take your data, you remove the dark, then you divide by the white while you have been removing also the dark. Sometimes we don't have really issues with high reflectance, but I would say we have more often issues with low reflectance object with a black plastic flow, for example. So here we recommend to use like dual integration time approaches. So that means you acquire the data and the white reference at different integration times. That's the way to proceed. Here, I think I can understand now what you mean, like high reflectancy. High reflectancy could be, for example, when you have glares. when you have objects which are not flat, but we have a shape. So basically you can see the specular reflection from the illumination. So here, basically, there is not much to do instead of like, yeah, you have burned pixels like they are saturated. Is it possible to calibrate the cameras radiometrically to obtain radiances? Yes, we do that. And it's an option we can provide with our cameras. So you can use them then for remote sensing application, like for emission. Our AFX cameras, they are always radiometrically calibrated. Chris answered, I think this is very interesting for multiple classifier. I don't know what it was for, but thanks for the thanks. Then, can we export all raw data for analysis using Python or ImageEye? Yes, basically, I don't know ImageEye, but I know Python. So basically, yes, you can acquire the data, and the data which are acquired with our software, they are like NV data type with BIL interleaves, and they are data type number 12 to the best of my memory. So here, if you type on Google what is NV data type number 12, you will have all the details. So yes, it can be open in Python in MATLAB without any problem, and then you can build your model up to you. What is the size of the smallest object that can be reliably detected? That's an interesting question, which is coming quite often. Well, let's speak about size of pixels, because you know the size of the pixels depend how far away you are from the object. So I would say it depends on the size of the pixels. Typically, I'm used to say when you want to detect an object and you want to classify it, it needs to have at least 1 or 2 pixels which are only related to the material. So if you have like a sample, which would be like my mobile phone, and you have 1 pixel at the middle, it's okay, you will get the spectral signature from this pixel and only from these pixels. If you have pixels which are like partly with the background and partly with the object, you may have a mixture of the spectral signature between the background and the object, and the detection is not really good. So I'm used to say that you need to have at least 2-3 pixels is better, which are really like only at the middle somehow of the object, or not mixed with the surrounding. Having said that, with the FX10, for example, if you use it at 10 centimeters away from the sample, the size of the pixel, it's about 70 micron. So it gives you an idea about the object you can detect, like 150 micron. With the FX17, the size of the pixel when you are that close, it's about 100 microns. So then it will be like close to 200 microns. That's the smallest you could do. Then a question that is maybe more application based. You mentioned moisture. Yes, I did. I am interested in processing for seafood, fish and shellfish. This would usually have high moisture content, but not be wet. Also, I appreciate that this is a fine line, okay? How would you think the classifier might perform in this kind of situation? Okay, so when you want to go with moisture level, then you need to go more like for regression model. And if you go for regression model, then it is not the PLSDA algorithm which is applied, but it's more like a PLS. And here the cube is not designed for that yet at the date of today. There are some other software available for this. I agree with you. There is a thin line between moist and being wet. I haven't tried on seafood, but have tried on meat, for example. And with the meat, we can really see what is the level of the freshness there because of the moisture. So I guess with the fish, you should be able to do the same to see if it is wet at 90% or if it is moist at 80%. That should be done. But again, here, the SpecimONE is not the platform for you to do that. I encourage you to use our camera, of course, but then to use some other. Okay, can you hear me still? Okay. Hello?
Yes, can. There was some.
Yeah, I had a bug. So my laptop had some fun, but it's okay. It seems that everything is fine again. I think you heard everything what I was saying about like other software house you may contact for this type of analysis.
Yeah, I think Matthew, it's also worth of mentioning that we do conduct feasibility studies. So yeah, this is definitely something that we could look together. Simply using first our camera to find out what we could do, and then okay, if it's not something really suitable for the SpecimONE concept, yes, we can definitely look also other software alternatives.
Okay, then Mateus was asking, just to double check, the communication from SpecimCube and sorting machine is one way. Currently, there is no control from the sorting machine to the SpecimCube. That is correct. So Jorma, do you have some input here? Or?
I would say, yeah, generally, yes. Like, okay, the SpecimCube is the one streaming the classification results to sorting machine, or let's say maybe there's a machine with software between. Is there a need to or let's say communicate with the SpecimCube? Okay, yes, you can install the model there. You can configure it. You can also use the triggers. So there is a triggering inputs as well as triggering outputs. So that level of communication obviously is possible. So there's lots of different interfaces available for us.
Just one thing, it is possible as well to use some triggering with a cube, so there is this capability as well. Okay, what is the differences of doing spectral imaging with IMEC sensor and your technology, please? Aha. So here we are going to another topic, because that's a good topic. So basically, our camera, they are working in such a way that, how can I explain? I use again my mobile phone. It's a great tool. You see the image, the object only with a line like this. Then you have the optical part here in the camera, and it's made of gratings and prism. And the component of the light with a longer wavelength, they are deviating downwards, and with a lower wavelength, they are deviated upwards. And behind, there is what we call a 2D detector, with here a spectral axis and here a spatial axis. And then, frame after frame, basically, you can acquire the spectral information. Here, with this way of doing, you acquire on a single pixel all the bands at the same time. Okay? With the IMEC camera, you have a filter, which is here, and different wavelengths. And then here you acquire all the wavelengths at the same time, but you look at different places as well. So for example, the red line is looking here, whereas the blue line is looking there, and so on. So here you have some issue of pixel co-registration when you have a target. You have an issue of pixel purity. For example, when you have an object, you saw it here at a certain wavelength, then it needs to move to see the next wavelength and so on. So you may have really like to make a software to correct these kind of things. So this is the main difference. With IMEC, you will have pixel co-registration issue. With our technology, you will not have. With IMEC, they also have the mosaic. So if it would be the IMEC detector, you also have a mosaic here. And then you have only 16 or 20 bands, I don't remember exactly, but you are not really talking about hyperspectral imaging. Yes, spectral imaging, I got it. Okay. So far, the actual state of the shutter, FX17E, has been toggled only, so one was not sure 100% if it is open or closed, at least used via the Perception Studio software. Did this change? Was there a firmware update adding this information? You seem to have a true state instead of a guess of your demo video. Okay, Jorma, do you have something to comment in here?
Well, I believe we do have a true state.
Okay. For every pixel in the sensor, will I be able to extract the intensity of the whole spectral range? Yeah, for every pixel of the line, yes. For every pixel of the line that you're looking at, this is true. The problem with voice, with my voice maybe, I don't know.
Yeah, that's the small issue you had before. Since that,
well, I think that was the last question. We went through all of them. Okay, anything we need to? Oh, there was a poll. Shall we look at the poll, by the way?
yeah, Harry, can you show the results somehow? Or we just communicate those? Okay, so the question was that in your opinion, following is the main challenge in using hyperspectral imaging technology. Cost of the camera, needs to build systems to detect materials, lack of easy-to-use tools, hyperspectral imaging system performance with industrial applications. And seems that the 44% are still considering that the cost of the camera is the main challenge when deploying the spectral imaging. Second one is the system performance with industrial applications with 24% of votes. Lack of knowledge to build the system to detect materials, 20%, and lack of easy to use tools, 11%. So thank you very much for your feedback. This will be also important information for us.
Yeah, it's important, and I have to say, when I started to work at Specim about like it's not 10 years ago, but soon actually. Time flies. I have to say the cost of the camera was much higher. Now it has been decreased. And that's why actually we can start to see them for the industrial application. But yes, we understand. Yeah, we understand if it will be really cheap, we understand it will be everywhere. But, you know, it's high tech still.
Absolutely. And then at least if looking at the second and third one, the system performance and then the knowledge to build these systems. Yeah, this is definitely something where the SpecimONE can help. So, like mentioned, we will make things easier and faster with the SpecimONE. So thank you very much for joining, and please do not forget to visit our website. You can get lots of more information about not only for the SpecimONE, you can see the great case studies, information about our cameras, etc. So yes, please do so.
Thank you. I think we are done. Thank you very much.